A warm welcome to all the viewers. In today's session of Tourism and Hospitality Research, I am going to discuss with you how you can easily do multiple linear regression in SPSS. There are certain assumptions for conducting multiple linear regression, which I have already discussed in my previous video. Just to give you a recap, the assumptions include normality of data, continuous nature of data, homoscedasticity of data, no multicollinearity issues, and the data should not have missing values. In case you have missing values, you do the imputation or you replace the missing values with certain procedures like replacing them with mean. So I have discussed all of these things in my previous video, the assumptions of regression and ANOVA. You can go back to that video to check on the assumptions. In this video, I'm going to particularly show you how to do multiple linear regression in SPSS practically with an example. So let us start. So here we are in our SPSS and we have the same data set which I have been showing you through all the examples. FQ stands for food quality. This variable has 4 indicators, each measured on Likert 5-point scale, where 1 stands for strongly disagree, 3 for neutral, and 5 for strongly agree. The second variable is cultural authenticity, CA, again 4 indicators. Third is service quality with 4 indicators. Value for money is the fourth one with 4 indicators, VM1 to VM4. Behavioral intention, which is the dependent variable, again with 4 indicators, BI1 to BI4. Now, all of them are ordinal in nature. You see here, I put in the ordinal mark because they are measured on Likert 5-point scale. Now, in order to analyze them for regression, I need to convert them to a continuous form. How can I do that? So first I need to take out the mean value, the arithmetic mean, which I have done over here. I have shown you in the previous video as well. So this is the mean for FQ, CA, SQ, VM and BI. Now they have come on scale. So that is how I made them continuous in nature. And this is a data of 204 respondents. You can see here, case ID 204. So there are 204 samples in my data. Now, how should I do multiple linear regression? Now, what is multiple linear regression? A regression analysis in which there are more than one independent variables and one dependent variable. So in this case, we have 4 independent variables, FQ, CA, SQ and VM, which are used to predict behavioral intention, BI, the dependent variable. So let us see whether there's a relationship between the independent variables and the dependent variable, and can they be utilized to predict the behavioral intention. So that is the role of regression. So for that, I'll go to analyze, regression, linear, and here I need to put in the mean values. So first I take mean of FQ in the independent, mean of CA, SQ and VM. So 4 independent variables, and the mean of BI, that is my dependent variable, like this. In the statistics bar, I click on R square change, I click on descriptives and I click on confidence intervals. That is what I need for now. I click on continue and click on OK. Now, I got the mean, standard deviation and number of samples in each variable. So you see 204, it's constant for all, there are no missing values, the mean and the standard deviation. This was the descriptives. Now I'll go to the model summary. So I use the enter method wherein all the variables entered together in my regression equation. There is a stepwise method, a forward method and a backward method as well. But in this video, I'll be discussing the most common, which is the enter method, wherein we enter all the independent variables together to predict the dependent variable. So I got the R square and adjusted R square. You can go with R square, which is the square of coefficient of correlation, which is R. So square of coefficient of correlation is coefficient of determination, that is R square value. So the R square in this equation is 0.378. That means 37.8% of the variance or the change in dependent variable is contributed by my independent variables, 4 independent variables together. Now I go to ANOVA. Now, if I want to see whether this contribution is significant or not, I go to the ANOVA table, and here I see that it is significant as the p-value is below 0.05. So once I've checked the ANOVA, I go to coefficients. Now, in this coefficients, how do I read this and how do I interpret it? Let us see for food quality. So the beta value, unstandardized coefficients. Remember that in regression, we always report the unstandardized coefficients. So that means for every unit change in my food quality, the behavioral intention will also positively change by 0.163 units. For every change in my cultural authenticity variable, the behavioral intention will change by 0.269. For every change in service quality, the behavioral intention, the dependent variable, will change by 0.375. Value for money, the behavioral intention will change by 0.071. So here we can see that service quality has the biggest impact upon behavioral intention. And whether it is significant, we go to this p-value table. This is p-value column. So it is significant and the value is lesser than 0.05. This is also significant, lesser than 0.05, also significant, significant. But value for money is not significant. That means value for money is not a good predictor, not a significant predictor of my behavioral intention, because the value p-value is above 0.05, it's 0.276. Rest of the three are good predictors, significantly predict my behavioral intention. Now, what is this t-value? T-value is the standardized value, and this has to be above 1.96 or below minus 1.96. So in this case, we see that FQ, CA, SQ, all of them have t-value above 1.96. So they are good to go. They are significant in predicting the dependent variable. But value for money has a value of 1.093, which is not significant. If I want to interpret the standardized coefficients, how do I interpret them? The beta standardized coefficients. So this is something which we can interpret in terms of standard deviation. So here I say that for every 1 unit of change in standard deviation, the standard deviation of my dependent variable will be affected by 0.136. For every change in standard deviation of cultural authenticity, the standard deviation of behavioral intention will be affected by 0.211. So this is how we interpret it in terms of standard deviation when we want to compare the standardized coefficients. Now what about 95% confidence intervals, lower bound and upper bound? How do we interpret them? So we interpret them as this value 0.163 will have a 95% chance to lie in between the lower bound and upper bound, which is mentioned over here. So that means the unstandardized coefficient of food quality will have 95% chance of lying between the lower bound and the upper bound interval 0.017 to 0.308. In case there's a zero coming in between the lower bound and the upper bound confidence interval, then that is insignificant, as we see in case of value for money. So here the lower bound is minus 0.057 and the upper bound is positive 0.200. So 0 lies in between them, and that is the reason it is insignificant in predicting behavioral intention. That is also shown in by the p-value and also depicted by the t-value. So this is how we interpret the results of our regression, and if we have a hypothesis like cultural authenticity is a significant influencer of behavioral intention. That was our alternate hypothesis. Null was it is not a significant influencer of behavioral intention. So in that case, if the p-value is below 0.05, we reject the null hypothesis because our p-value is significant. So as in this case, the p-value is 0.029, which is below 0.05. So we reject the null hypothesis, which was that FQ is not a significant influencer of BI. And we go with the alternate hypothesis, acceptance of the alternate hypothesis, and say that food quality is a significant influencer of behavioral intention. So this is how we interpret multiple linear regression results. I hope the video was quite informative and useful for all of you. And now you can go ahead and confidently write down the results in your paper, in your thesis, in your dissertation, whenever you are conducting multiple linear regression. So thanks for watching and keep watching for more.